Hello students, I hope that you are good, well and fine. Today we will be continuing our discussion on the topic of ITF, which is inverse trigonometric function, and inverse trigonometric functions. We will be seeing properties of inverse trigonometric functions. Let's see. So what property we will be covering? We saw this, okay, and now we will be seeing the odd, that sine inverse function is also odd function. Cos inverse function is cos inverse of minus x is what? Pi minus cos inverse x, and sine inverse x plus cos inverse x is equals to pi by 2. Okay, this will be our main focus, and there are other properties you will be seeing, okay, apart from these. Okay, let's move. So if y is equals to sine inverse x, okay, then x is equals to sine y, and if x is equals to sine y, then y is equals to sine inverse x. This is equivalent to this. Okay, so sine of sine inverse x is x only when this x belongs to this interval, closed interval -1 to 1, and sine inverse of sine x must belongs to sine inverse of sine x is equals to x only when sine when x belongs to what? Closed interval -1 to 1, or the principal value of sine inverse function. Okay, so that's it. Okay, now what? Now let's see this identity. Okay, that sine inverse of minus x is equals to minus of sine inverse x. This means, this says that my sine inverse function is what? Odd, as like the sine function, as like the sine function. Okay, let's see proof. So we will be starting with this side, the left hand side. So putting this expression equals to y, and from this must know that this y must belongs to where? The principal value branch, which is minus pi by 2 to pi by 2. Don't forget this. Okay, now what? Now we will write minus x is equals to sine y. Okay, now x is equals to minus sine y. Okay, and we know what? We know that sine function is what? Odd function. Sine function is odd function. So from here what we can write is this, because sine function is odd function. Okay, that's why we can write x is equals to sine of minus y. Okay, now what? Now what we will do? Just nothing. We put these values as sine inverse x. Now sine inverse x is equals to minus y. Yes, and y and this we know that y value was, we took sine of minus x is as equals to y, and then we will be substituting this value of y, which is sine inverse minus x, in here. So what you will get is sine inverse x is equals to minus of sine inverse minus x. Further, this will imply what? That sine inverse minus x is equals to minus of sine inverse x. Okay, so I hope that it is quite clear to you. Now you can use the similar concept of proof into this, and what you will be getting is cosec inverse minus x is equals to minus cosec inverse x. So this is also what you can say, odd function. Okay, and tan is also odd function from this. As you can see, tan inverse of minus x is equals to minus tan inverse x. Okay, So this tan inverse is also what? Odd function. So if you try to make some observation, what observation? Normal function sine, cosec, which is what? 1 upon sine, and tan x, which is what? Sin x by cos x. These all are what? Odd functions. And in inverse trigonometric function, the sine inverse, the cosec inverse, and the tan inverse, they are also what? Odd functions. Okay, this one is interesting. Okay, now let's move next. Now cos inverse of minus x will be what? Pi minus cos inverse x. Okay, let's prove. So we will start with the left hand side, putting it equals to y. Okay, and we know that this y must belongs to the principal value branch, which is 0 to pi closed interval. From here, what I can say is that minus x is equals to what? Cos y. Okay, we know that cos inverse function is defined from minus 1 to closed interval 1 to 0 to pi. And from this also I can say that this minus x must belongs to the domain of this. So this means this. Okay, keep this point in mind. Okay, if they will use, I will tell. Now what we can write is minus x is equals to cos y. Okay, now multiply with a minus sign both side. What you will get? X is equals to minus cos y, and minus cos y, you all know, whenever you face minus sign just before the cos, what you will write? You just do nothing, write cos first, then pi, then put this minus sign over here for your convenience, and then put the theta used over here, which is y. So you will get the another way of representing this thing. Okay, so now minus cos y is equals to cos of pi minus y. Okay, now what you can do is put inverse. So now cos goes to x, then it will become cos inverse x is equals to pi minus y. Now the value of y from this, what you can say is y is equals to pi minus cos inverse x. And the now what we will do, we will put the value of y over here. So what you will get? The cos inverse x minus ax, cos inverse minus ax will equals to be pi minus cos inverse x. Yes, so this was the thing we need to show, as you can see over here. Or the other way to write it, as we can say that taking this to the left hand side and this to the right hand side, you will get this expression, this equation. Okay, so cos inverse x is equals to pi minus cos inverse of minus x. Okay, so you write this or you write this, the both same thing. Okay, I hope that now it is clear to you. Okay, so let's move to next. Now on the similar pattern, what we can say is sec inverse minus x is what? Pi minus sec inverse x. Okay, this is comma. Okay, and if you recall, let me give you the domain and the range for inverse trigonometric function. If you recall, sine inverse is defined from where to where? The minus 1 to 1 to closed interval minus pi by 2 to pi by 2. Cos inverse is also defined from minus 1 to 1 to but closed interval 0 to pi. The say sec inverse, not the sec, say tan inverse. Tan inverse is from where to where? It is from R, not yes, it is from R to what? Open interval minus pi by 2 to pi by 2. Now cot inverse, if you recall from the graph, that cot inverse graph looks like this, okay. So this is what the zero asymptote, and this is what the pi, okay, pi, and this value is what, this value is 0 at pi by 2, okay. So from here, as you can see that it is defined from where to where, so it is 1 1. So your range will be what, the r to what, open interval 0 to pi, okay. Now what, now for sec and cosec inverse, okay. If you recall the sec graph, so the sec graph is from cos graph, as you can see over here, okay. So what you will do is first of all try to make the asymptotes wherever the cos graph is 0, hits this line x-axis, and then you put like this. So what you can see over here is this point is 0, this point is what, pi. So it is defined from, as you can see that your domain will be r minus open interval minus 1 to 1 to what, as you can see 0 to pi, the closed interval 0 to pi, but eliminating this point pi by 2. Now for cos inverse, if you can see, the cos inverse function is coming from the sine. Now we will make the vertical asymptotes wherever sine is 0. Now what, now making parabolas like this, as you can see it must be 1 1, it is 1 1 from this to this interval. So the cos inverse function is as you can see is defined from where to where, the all real number except open interval minus 1 to 1 going to what, the principal value branch is what, minus pi by 2 to plus pi by 2, okay, the closed interval, but eliminating this 0 point, okay, as you can see now, okay. So sine inverse is easy, cos inverse is easy, tan inverse is easy, cot inverse is easy. The only difficulty you sometimes face is with sec and cosec inverse, and if you know the graph for sec and cosec, you can easily make the domain and the range. You do not need to any thing to memorize, okay. So the domain remains the same, as you can see in these pairs. For cos and sine inverse, the domain remains the same. Tan inverse and cot inverse, domain remains the same. Sec inverse and cosec inverse, domain remains the same, okay. And okay, I hope that it is clear to you. So you must know, in order to solve the inverse trigonometric function problems, you must know this thing, the domain and the range of the respective inverse trigonometric functions, okay. So now, as you can see, what, the sec, okay, the sec domain is what, as you can see, the sec domain is, you can say that this thing, this is what, this is nothing but all this is what, all real numbers except in this interval. So other way to write this is like this, okay, the closed interval union, the closed interval 1 to infinity. And the another way to write this is that the, if x belongs to this or this, or this means x is this, this is also the same way to represent this and this, okay. So as you can see, the domain, sorry, yes, the domain. So for sec inverse of minus x is equals to minus pi minus sec inverse of x. The cot is, cot inverse of minus x is what, pi minus cot inverse x, where x belongs to where. So cot inverse, as you can see, the domain. So domain is whole R, okay. As the results follows the same, but for tan and cosec it is odd. as you can see, odd functions. And sec inverse, as we saw here, this is the same thing above, written above. Okay, so the same thing written above. Okay, so I am leaving these properties to prove for you, so that you can also try them. Okay, so please try them to prove. Okay, let's move to next. Now the more properties. Now sine inverse x is what? Cosec inverse 1 by x. Okay, cos inverse x is equals to sec inverse 1 by x. If you see that, we know that sine x is what? 1 by cosec x. Yes, we know this. Yes, or just we can say that sine a is equals to cosec a. Yes, if what? That what you will do, take sine inverse x, put it equals to a, x will be what? Sine a, and sine a will be what? 1 upon cosec a. Yes, and this, from this what I can say is cosec a is equals to 1 by x, and from this what I can say is a is cosec inverse 1 by x. Yes, so from this what I can say is sine inverse x is equals to cosec inverse 1 by x, as written over here. Yes, quite easy. In the similar manner you can prove this. I hope that you can easily do it. From where, what relation we will be using? Quite easy relation. What? Which is cos a is equals to 1 upon sec a. Okay, from this what you can say is, I'm just doing quickly. So taking cos inverse x is equals to a, x is equals to cos a is equals to 1 upon sec a, and from this what I can say is sec a is equals to 1 upon x, and from this what I can say is sec a is equals to sec inverse 1 upon x. So this will be what? Sec inverse 1 upon x. Yes, proved. Okay, for tan inverse you can also do without facing any difficulty. Okay, so okay, so now I am leaving the remaining ones to you, so that you can try it by yourself and get the better idea of how trigonometric functions and how inverse trigonometric function works. Okay, let's move to next. Okay, next. So the proof is there for this identity. Okay, if you recall, in a normal trigonometric function, we saw the cos the sine square x plus cos square x is equals to what? 1. This is the most important property we used time to time. Yes, in normal in normal trigonometric functions. In inverse trigonometric functions, this is the you can say this property is the similar to that property we just wrote. Okay, this is also very important. Okay, let's see the proof. So sine inverse x plus cos inverse x, we need to show that it is equals to pi by 2. So how we are going to show? Quite easy. Start with this thing. Okay, then find what we will find the principal value, and for this also we try to find the principal value. Okay, so taking sine inverse x is equals to y, then y the x is equals to sine y, and sine y we will convert sine y to cos. Because why? Because we also have the cos function over here. Okay, so sine a is equals to cos of what? Pi by 2 minus a. So we will be using this thing. So sine y is equals to what? Cos pi by 2 minus y. Okay. And then what? Then we have arrived to this point, which is x is equals to cos pi by 2 minus y, and from this what I can say is cos inverse x is equals to pi by 2 minus y, and from this I can rewrite the value of y, and the y will be what? Y will be, as you can see, y will be what? Pi by 2 minus cos inverse x, and we started from where? We started from cos inverse x is equals to y, and the value of y is pi by 2 minus cos inverse x, and from this what I can say is that sine inverse x plus cos inverse x is equals to what? Pi by 2. Okay, I hope that it is clear to you. Okay, now in similar manner you can prove for tan inverse. Tan inverse x plus cot inverse x is also equals to pi by 2, and you can in similar manner prove cos inverse x, cosec inverse x plus sec inverse x is also equals to pi by 2. Okay, I am leaving this for you. Okay, these are simple ones. Okay, you start with this, you will eventually end up getting this whole term as you got over here. Okay, you start with this, or you can either start with this also. You will end up with something like pi by 2 minus cosec inverse x. Okay, I hope that you can easily prove them without facing any difficulty. So let's move to next. Okay, now the another most important property is for tan inverse x plus tan inverse y. Okay, tan inverse x plus tan inverse y. If you recall, in normal trigonometric function, the tan a plus b is equals to what? Tan a plus tan b by 1 minus tan a tan b. 1 minus tan a tan b. In inverse trigonometric functions, it is equals to, it is divided, actually divided into subparts. So first of all, if your product is negative, the xy product is negative, what you will get, if this and this product is negative, then what you will get is tan inverse of x plus y 1 minus xy. Same as this, as you can see, this, suppose this is your some x, this is y, then 1 minus xy. Somewhat similar. Okay, not properly, but somewhat you can make sense. Okay, and if the product is greater than 1, then you will have the extra pi over here. So let's see the proof. So we have tan inverse x plus tan inverse y is equals to what? We can rewrite it as, we can easily rewrite it as tan inverse, we want this proof. Okay, so start with this, taking tan inverse x is equals to alpha and tan inverse y as equals to what? Beta. Then from this what I can say is x is equals to tan alpha, and from this what I can say is y is equals to tan beta. Okay, from this what I have is just now evaluate this, tan alpha plus beta. Tan alpha plus beta, use this formula, what you will get? Tan alpha plus tan beta 1 minus tan alpha tan beta, and I know that tan alpha is what? X, tan beta is what? Y. Just replace all the values, what you will get. So we have tan alpha plus beta, where tan alpha is x, tan beta is y. Yes, this is what we have. Okay, now this is equals to tan alpha plus tan beta by 1 minus tan alpha tan beta, and from this what I can say is that tan alpha is what? X, tan beta is what? Y, tan alpha tan beta is what? xy. Okay, and from this alpha plus beta is equals to tan inverse of x plus y minus 1 minus xy, and we know this, what it is? Alpha is equals to tan inverse x and beta is equals to So alpha is equals to tan inverse x and beta is equals to tan inverse y. Tan inverse y, as you can see, we proved. Okay, so this was the thing we need to show and we showed it. Okay, now let's move to next. Okay, let's move to next. So if the product is a negative, then you will get this, and if the product is if the product is what, positive, you get the extra pi over here. Okay, so okay, sorry, let me give you again, go through it. So in previous, the x and y, as you can see, is both positive, and in this case this, then the product is negative, then you will get this. Okay, you only can apply this formula when the product is negative, the product is smaller than 1, but individually x and y are positive numbers. Okay, and if the product is greater than 1 and individually they are greater than 0, then you will get extra pi over here. Okay, now in next we are seeing that individually x and y are negative. Okay, don't confuse, x and y here are negative, and in this case if it is less than 1, then you will get this. Okay, and if it is I think here it will be greater than 1, then you will get extra minus pi over here, minus pi, in case when you will be having this case. Okay, I hope that it is clear. So I'm not going to prove, because the proof is very quite messy. Okay, messy in the sense that you will be facing say difficulties to understood. So I'm just giving you the formula so that you can easily apply it to solve problems. Okay, so we are just omitting the proof. Okay, now let's move to next. Now we will try to solve examples. Okay, so this shows that sine inverse 2x root of 1 minus x square is equals to 2 sine inverse x. Okay, what this means, it is equals to this whenever this happens. Okay, let's see how we are going to prove. It is quite easy. Start with this left hand side. Okay, start with this left hand side, 2x root 1 minus x square. Now in such questions, what you will do, try to put x is equals to some trigonometric function, some trig functions. Okay, and try to remove any root if there. So as you can see over there, so 1 minus x square like this. So what I can put in place of x, so that I can easily remove this. So if you know what, that 1 plus tan square x is equals to sec square x. Yes, from this what I can say is tan square x is equals to sec square not, I cannot use this. Okay, no problem. Now what, let me use different. So yes, 1 minus sine square x is what, cos square x, or 1 minus cos square is what, sine square x. So if you put you can either take x is equals to sine x, or take x is equals to cos x. Your objective to remove the under root will be served. Okay, how? Let's see. If you put I am taking x is equals to sine x, then 1 minus sine square x is what? It is cos square x, and this will be what? Cos x. So this means sine inverse of 2 sin x cos x, and this is what? 2 sin x cos x is sin 2x, and from this what we know is that this is equals to 2x only when 2x is from where to where? 2x must be from minus pi by 2 to pi by 2. Yes, it is from minus pi by 2 to pi by 2, if you recall. Yes, so sine inverse of sine 2x is equals to, if you recall, sine inverse of sine a is equals to a only when a is from where to where? A is from pi by 2 to minus pi by 2 to pi by 2, closed interval minus pi by 2 to pi by 2. Okay. Okay. Now, from this, what I can say is quite easy, is that this 2x is now belongs to pi by 2 to minus pi by 2 to pi by 2. This means minus pi by 4 to what? Pi by 4. And from this, what I can say is, so, oh sorry, so x I am putting as theta, not x is equals to sine a. X is some sine function in terms of theta, so sine theta, sine theta. So here it will be what? Sine 2 theta, so sine 2 theta. So this theta will be from where to where? This theta will be from minus pi by 4 to pi by 4. So from this, what you can say, if this theta is from minus pi by 4 to pi by 4, and we know what we know, that, so this means if you see the sine function, so sine function, sine theta function, this is sine theta and sine theta. So theta belongs to where? Minus pi by 4 to pi by 4. So somewhere here we will be having pi by 4, and somewhere here we will be having plus pi by 4. As you can see, at value minus pi by 4, we will be having minus 1 by root 2. At this, what you will be having? 1 by root 2. So from this graph, you can see your sine theta, for this case, this imply your sine theta must belongs to the closed interval minus 1 by root 2 to 1 by root 2, and sine theta is what? Sine theta is x. So this means x belongs to the minus 1 by root 2 to 1 by root 2. So indeed it is equals to 2 theta, as it is given like this, and theta is what? You can say from this that theta is equals to sine inverse of x. So theta is equals to sine inverse of x. So we showed it is equals to this. So I hope that it is clear to you. Now, if you put in second part, if you put x is equals to what? X is equals to what? Cos theta, then you will get this. I hope that you will do it by yourself. So that's it for today. We will be stopping here. So thank you. We will be meeting next time. Thank you.